Here we go. Okay, this is Algebra 1. We're all the way to week number 12 study guide. Write the polynomial in standard form. If you see that, it just means write the degrees going down or decreasing. So the largest degree is the third power. So negative g to the third power is first. The next one is g to the second power. So plus 3g to the second power. The next one is positive 4g. It doesn't have the plus in front of it, but you know it's positive. So plus 4g. And then the last one is negative 2 with no g. That's standard form. Simplifying the difference for number 2 and number 3, all you're doing is the opposite of everything it says in the second one. When you say minus a negative, it means plus 7x to the 4th. So if you need to rewrite that as plus 7x to the 4th, it might help you out. Minus a negative 5 means plus 5, and minus a negative 9x means plus 9x. So just do addition with all of these now, and you'll treat it just like addition. Negative 7x minus 5x to the 4th plus 5. You can use the vertical or the horizontal method. Some of y'all were saying you prefer the vertical method yesterday. That's fine. Negative 5x to the 4th is going to come first. It's the biggest degree. Plus 7x to the 4th. So negative 5 plus 7 leaves you with 2x to the 4th. Negative 7x to the first power is next, plus 9x. Again, negative 7 plus 9 is positive 2x, and it's to the first power. And then the last one, did that one a second ago. The last one is positive 5 and positive 5, so plus 10 would be what you'd have for number 2. Okay, you don't have to rewrite everything. Here's how you would do it without rewriting it. W to the third power is your biggest degree. So 4w, I'm sorry, to the second power, 4w squared minus 2w squared. 4 minus 2 leaves you with 2w squared. Negative 4w minus 3w. Negative 4 minus 3 is negative 7w. And negative 8 minus negative 6. Minus a negative, remember, means plus 6. So negative 8 plus 6 is minus 2. Number 4, you're simplifying the sums. Again, the biggest degrees first. 4u plus to the third plus 6u to the third, 10u to the third. 4u squared plus a negative 2u squared, which means 4 minus, one of them is u squared, the other one's not. So plus 4u squared is next. Then you have minus 2u all by itself. And then plus 2 plus 8, so plus 10 for that one. Number 5 says solve the equation, check your solution. You have to undo the subtraction of 2 first, so add 2. 5 equals the square root of g. Just treat it like it says the square root of x. Undo the square root of something by squaring it. Do the same here, so g equals 5 squared is 25. Difference between number 5 and number 6 is plus 5 is under the radical, so you can't do subtract 5 like you undid minus 2 a minute ago. So you have to undo the radical first by squaring it. That'll cancel it out. D plus 5 equals 6 squared is 36. Subtract 5 on both sides. D equals 31. Number 7 says the square root of 3x plus 10. Number 7 says the square root of 3x plus 10 equals the square root of x plus 4. We had looked at an example that looked exactly like this, but how do you undo the square root of something? You square it. So if you square one side, you square the other side, and it cancels out both of them. Cancels out both of them. So what you're left with is 3x plus 10 with no radical equals x plus 4. So all you're left with right here is a problem that has variables on both sides. Bring your smaller x, your 1x over here, over to the 3x side. So it's positive, so subtract 1x. You do it there, do it here. That leaves you with 2x plus 10 equals, it's going over here now, 4. Get rid of plus 10 on the left by subtracting it. 4 minus 10 is negative 6. So you have 2x since these canceled out. Divide by 2 to cancel that part out. And x equals, for number 7, negative 3. X equals -3. Number 8 asks you for the radical to simplify 63. 63 is not a perfect square. Had it said 64, we could just put the number 8, but it didn't. So we need to use one of our perfect squares. 2 times 2, 3 times 3, 4 times 4, 16. 5 times 5, all of those numbers. Which one can I multiply by? 9 is your best one. So 9, or the square root of 9, times the square root of 7, because 9 times 7 is 63. What is the radical, or what is the square root of 9? 3 times the square root of 7. There's no perfect squares in 7, so that's simplified. Number 9 kind of snuck up on there. You won't have a variable in the bottom like that, but I'll show you how to do it nonetheless. You would separate this into the square root of 11 over the square root of 9 times the square root of n to the 4th. Just like squaring something cancels out the radical square root, taking the radical of this one just makes it into n squared. It just turns it from the 4 to 2. But again, don't worry too much about that one. I just wanted to show it to you. The square root of 9 is 3. So at the bottom, you have 3n squared. And on top, you have the square root of 11. There's no radical that goes into 11. That's perfect. So that's one of the questions that's right. The other questions say, is there a radical at the bottom of the fraction? No is the answer to that one. And is there a fraction under the radical? No is the answer to that one. So believe it or not, that is the simplified version of number 9. Number 10 says 3 times the square root of 44. So separate 44 into perfect squares. 4 times 11. That gives you 44. Don't forget, however, though, this will be where the mistakes made to bring down that 3. So what you have now is 3 right next to the square root of 4. We know that the square root of 4 is 2, and they're right next to each other, so it's 3 times that, times the square root of 11. Or when you put those two together, 6 square root of 11. For number 11, it says the square root of 250 divided by 10. When you divide right away the square root of 250 by 10, it gives you 250 divided by 10 is the square root of 25. And the square root of 25, or what times itself is 25, we all know is the number 5. Solve these equations using square roots. So this is going back to last week. 6x squared equals 54. Divide by 6. Do it here. That'll cancel it out and leave you with x squared equals 9. Undo squaring something. Up until this point on this study guide, we've been undoing the radicals using squares. Now we're undoing squares using the radicals. So do it there and here. X is equal to 3. Do the same thing for this one. Undo minus 15 by adding 15 to both sides. And that gives you 49 right there, equals x squared. Undo squaring something again, just like on number 12, by taking the square root of it. X equals 7. But times itself is 49. Then we're simplifying faster problems. Anything to the 0 power, anything being raised to the 0 power is 1. Now, 6 is being raised to the -2. It makes it abundantly clear on this one because it's inside the parentheses and the negatives out front. Anytime something being raised to a negative exponent, it looks like this. -6, it's over 1 to the -2. All this negative value means, all it means is to make it ride that elevator down. So 6 to the -2 would go down, and it would become -1 over 6 to the +2. Again, on this fraction, it's not going to matter if you leave the negative at the top or the bottom because the whole fraction is going to be negative. But it stays up there according to the way it's written. So that gives you -1 over 6 squared, which is 36. -1 over 36. That's number 15. Then it says 15 times 5 to the -4th. Again, just like number 15, now it has a negative exponent. It rides the elevator and it goes down. It's over 1 already. It becomes 1 over 5. Now it's to the +4th. I'm going to bring this part over here. Times 15 over 1. I just reversed the order to make it fit. So 1 over 5 to the 4th. 5 to the 4th. 5 times 5 is 25. Times 5 is 125. Times 5 more is 625. So we have 1 over 625 times 15 over 1. So we know the number, if you multiply straight across, you get 1 times 15, which is 15, and 625 times 1, which is 625. We know the number 5 goes into both of these numbers since they both end in 5. 5 times 3 is 15, and 5 goes into 6 one time, and it goes into 25 5 times. Again, we don't have a simplified fraction at this point, even though I circled it. Remember, it has to, there's a number 3 that goes into both of those. 3 goes into this one time, and it goes into this one. Okay, we had a little mistake right there. 15 over 625. The number 5 does go into them. It goes into 15 3 times, and it goes into 625 125 times. That makes better sense. 3 over 125 is your simplified version, finally, of number 16. Number 17, you're multiplying the same bases. There's no coefficient shown right here, 1, but if you multiply 1 times 6, you're still going to get 6, so there's no reason to even write it. But you do have the same bases, x to the negative third times x to the fifth. Remember, anytime you multiply the same bases, you add the exponents. So it's 6 to the negative third plus 5, which gives you 6x. Negative 3 plus 5 is to the second power. The difference between 17 and 18 is you're raising a power to a power for 18. K to the third. Now you multiply the exponents. K to the 3 times 3, which is k to the ninth. Do the same thing for number 19, but you have to give the third power on the outside to both the 5 and the g to the 7th. So 5 to the third power, g to the 7th times 3. So 5 to the third, we know 5 to the third is 5 times 5 is 25, times 1 more 5 is 125, and g to the 7 times 3 is to the 21st power. Then you're dividing the same bases. 3 to the 10th divided by 3 to the 9th. Anytime we were multiplying the same bases for these here, we added the exponents. When you divide in the same bases like 3, you subtract the exponents. 3 to the 10 minus 9 is 3 to the first power, which is simply 3. The same thing with number 21, m to the 5th over m to the 9th, but it becomes m to the 5 minus 9. This gives us a unique thing, or something different that we have to do. 5 minus 9 is m to the negative 4th. You can't leave it in that form. You can never leave negative exponents. It's got to ride the elevator down, and it becomes 1 over m to the positive 4th for that one. Okay, it's instead of being a 9, it's actually an 8, everybody. It's not going to change anything except the number's going to go, instead of saying 4, it's going to say 3. Okay, so it's negative 3, but it still rides the elevator down, and it becomes to the positive third when it's on the bottom. So make that switch from 4 to 3. And then you're doing the same thing for 22. X to the third over x to the negative 1. So that becomes x to the 3 minus negative 1. Okay, y to the negative 12 minus negative 7. Minus a negative. Remember what that means. It means plus. Minus a negative means plus. So 3 plus 1 is x to the 4th power. Y, negative 12 plus 7 is y to the negative 5th. Look and see which one's raised to a negative exponent. Y is. It has to ride the elevator down. So x to the 4th stays on top. Y turns into the positive 5th when it goes down. Both m and 6 for number 23 are being squared. So m is being squared, and 6 is being squared. So m squared over 6 squared, which is 36. Then you have like radicals right here. 2 square root of 3 minus 3 square root of 3. You just do, there's a like radical, so you do 2 minus 3, which is negative 1, or negative square root of 3. The square root of 7 times the square root of 6 minus 5 square root of 24. It's not the same radicals now, but we have to break the square root of 24 down. The square root of 4 is a perfect square of it times the square root of 6, which is 2 square root of 6. So that right there is the same thing as that. So what you have now, you should grab a different color. What you have now is 7 square root of 6 minus 5 times 2 square root of 6. That's just breaking the square root of 24 down. What you have to do here is multiply negative 5 times 2, which is negative 10 square root of 6, Bring the rest of it down. 7 square root of 6. 10. 6 it's supposed to say. 6. Now you have the same radicals. Both of them are 6. So do 7 minus 3, which is negative 3 square root of 6. That's 20. So when you subtract 7 and 10, you get negative 3 square root of 6. Distribute the square root of 10 to everything in 26. The square root of 10 times the square root of 15 is the square root of 150. The square root of 10 times 1 is plus the square root of 10. Okay? There's no perfect squares inside the square root of 10, but there is one inside the square root of 150. So break it down. The number 25 multiplies by something. It multiplies, well, in $1.50, you know that there's 6 quarters. So times the square root of 6. So 5 square root of 6 plus, we'll just bring this one down, the square root of 10. There's no perfect squares in either 6 or 10 to break them down further. And you don't have like radicals, and there's no fractions. So this is considered a simplified version of that radical problem. Then you're writing scientific notation and standard notation. A big number, a really large number for the first one, 70,300,000. Remember, for scientific notation, the number's got to be between 1 and 10. So the only spot you can put this number or the decimal is right there. So 7.03 is what the number has to be, times 10, and just count how many times you have to move your decimal from it starts right here. 3 times, 6 times, 7 times, times 10, and it's positive 7. Since it started off as a very large number. When you go in the other way, making standard notation, notice number 28 starts off as it's a negative number. So that means it's going to be a very small number. So you have 9.79. You're going to move it 4 times, it tells us, but we're going to make a small number. 1, 2, 3, 4. And we're going to fill in all of those spots. 0.000979.